The Last Signal. Amelia Earhart and the DNA Search. Forensic researchers found, when they applied next-generation DNA sequencing to bone fragments and environmental samples recovered from a remote coral atoll in the Central Pacific Ocean, the closest thing science has yet produced to a direct answer about what happened to Amelia Earhart. And the question that answer raises is one that aviation historians, forensic genealogists, and the United States Navy have been arguing about for nearly 90 years. Amelia Earhart was 39 years old in the summer of 1937 when she attempted to become the first person to circumnavigate the globe along the equatorial route, the longest possible path around the planet. She had already crossed the Atlantic solo in 1932, set multiple speed and altitude records, and accumulated a public profile that made her the most famous aviator in the world after Charles Lindbergh. She was also, by the mid-1930s, a calculated public symbol, a figure that publishers, politicians, and the emerging aviation industry deployed deliberately to demonstrate that aviation was safe, modern, and open to everyone. The aircraft was a Lockheed Electra 10E, heavily modified for the record attempt. 2 additional fuel tanks had been installed in the cabin, extending the range to roughly 4,000 miles. The cockpit had been rebuilt. The windows had been reduced to improve aerodynamics. The plane carried the most advanced navigation equipment available to civilian aviation in 1937, including a radio direction finder that, as events would demonstrate, was either improperly calibrated, inadequately tested, or both. Her navigator was Fred Noonan, widely considered one of the best celestial navigators in aviation at the time. Noonan had helped chart Pan American Airways' Pacific routes. He had one documented problem: alcohol dependency that had cost him his position at Pan Am. Earhart hired him anyway, trusting his skill. By July 1937, they had flown approximately 22,000 miles. One leg remained. Radio logs found in the National Archives document the final hours of Amelia Earhart's flight in a record of fading signals and failed contacts that remains, decades later, one of the most analysed and most disputed communication records in aviation history. The flight from Lae, New Guinea to Howland Island departed on July 2, 1937, local time. Howland Island is a flat coral strip, roughly 1 mile long and half a mile wide, rising barely 6 feet above sea level in the middle of the Central Pacific. To find it from the air required precise navigation across 2,500 miles of open ocean with no intermediate landmarks. A United States Coast Guard cutter, the Itasca, was stationed at Howland specifically to provide radio guidance. The communication problems began almost immediately. Earhart and the Itasca were attempting to communicate on different frequencies at different times. The Itasca transmitted homing signals that Earhart apparently could not receive clearly, and Earhart's transmissions to the Itasca were intermittent and difficult to interpret. At 7:42 in the morning, Howland Island time, the Itasca received Earhart's voice. She reported clouds and overcast conditions, said she could not see the island, and gave a position estimate that her fuel level suggested was too far north or south of Howland to easily correct. At 8:43, she transmitted a bearing request and reported that fuel was running low. She estimated 1 hour remaining. The Itasca transmitted continuously on full power. The crew could hear her signal clearly enough to know she was close, but the radio direction finder equipment, which should have allowed both parties to triangulate each other's position, was not functioning as intended. The Itasca could not establish a bearing on Earhart's signal.
Earhart, for reasons that have been debated ever since,
could not receive the Itasca's transmissions on the frequency she was monitoring. There was no further confirmed transmission from the Electra. The search that followed was the largest and most expensive in American naval history to that point. More than 200,000 square miles of ocean, 17 days, $4 million, 66 aircraft, and 9 naval vessels. No wreckage, no oil slick, no personal effects, and no trace of the aircraft or its occupants was found. Colonial administrative records found in the British National Archives document a discovery made on the uninhabited island of Nikumaroro, then known as Gardner Island, approximately 350 miles southeast of Howland, that was reported in 1940 and has been at the center of the most credible alternative theory about Earhart's fate ever since. A British colonial officer named Gerald Gallagher, who was attempting to establish a settlement on Nikumaroro as part of a Phoenix Islands resettlement program, reported finding a partial human skeleton on the island's remote southeastern shore in October 1940. With the bones were artifacts: a woman's shoe of a size consistent with Earhart's documented foot size, a man's shoe, a sextant box of a type used for celestial navigation, a bottle of Benedictine liqueur, and a box that may have contained a navigational instrument. Gallagher's written reports, recovered from the British Colonial Archive, describe his own conclusion that the bones might be connected to Earhart's disappearance. The bones were sent to Fiji for examination. A physician named D.W. Hoodless examined them in 1941 and concluded they were from a stocky male individual of European origin. The bones were subsequently lost, misplaced during the administrative disruptions of World War II, and have never been relocated. The loss of the original material is the central forensic problem of the Nikumaroro theory. The remains that might have answered the question definitively are gone. In 1998, forensic anthropologist Richard Jantz of the University of Tennessee applied modern statistical methods to the measurements Hoodless had recorded and reached a substantially different conclusion. The bone dimensions, Jantz argued, were consistent with a tall woman of Northern European ancestry, and specifically consistent with Earhart's known measurements, rather than with the male profile Hoodless had suggested. This reanalysis was peer-reviewed, published in the journal Forensic Anthropology in 2018, and changed the scientific standing of the Nikumaroro hypothesis from speculative to genuinely credible. Forensic genealogists found, when they initiated a systematic effort to obtain usable DNA from materials associated with Amelia Earhart, that the challenge of establishing a reference profile for comparison was as complicated as the challenge of finding biological material from the crash site itself. Earhart left no direct descendants. She had no children. Her husband, George Putnam, remarried after she was declared legally dead in 1939. Her only surviving close relatives when the DNA investigations began were nieces and nephews, children of her sister Muriel, whose mitochondrial DNA, inherited through the maternal line, would match Earhart's only if the maternal lineage was correctly identified and verified. The Tiger Organization, the International Group for Historic Aircraft Recovery, has conducted more than a dozen expeditions to Nikumaroro since 1989, recovering artifacts, soil samples, and bone fragments from various locations on the island. Bone fragments recovered in 2011 from a site on the island's western end were submitted for DNA analysis at a laboratory in Texas. The fragments were small and heavily weathered. Decades of tropical heat, humidity, and ultraviolet exposure had degraded the genetic material to a degree that the extraction techniques available in 2011 could not overcome. The analysis confirmed the fragments were of human origin, consistent with a female individual, but could not establish ancestry with sufficient confidence for a meaningful comparison. In a separate line of investigation, researchers at the University of Oklahoma identified postage stamps and envelopes from Earhart's personal correspondence as potential sources of salivary DNA. This technique, recovering DNA from dried saliva on historic envelopes, has been used successfully in other forensic genealogy cases. The Earhart correspondence is held at Purdue University Libraries and the Schlesinger Library at Harvard. Specific items were identified for sampling based on condition and provenance, but the analysis has not yet yielded a complete mitochondrial profile suitable for comparison against the reference sequence established from her verified maternal relatives. Archaeological evidence found on Nikumaroro by taiga expeditions over 3 decades has accumulated into a body of material that, taken together, supports a specific and detailed reconstruction of what may have happened to Earhart and Noonan after their radio contact with the Itasca ended. The castaway hypothesis proposes that the Electra, low on fuel and unable to locate Howland Island, turned south along a line of position that Earhart had established during the final approach and followed it until they spotted land. Nikumaroro is consistent with that navigation. The island has a relatively flat coral reef platform on its western end, where a small aircraft might have landed on the reef flat at low tide, a possibility that Taiga's analysis of tide tables, the aircraft's known fuel consumption rate, and the timing of Earhart's final transmissions supports as physically plausible. Earhart and Noonan could have survived the landing and lived on the island for days or weeks. Nikumaroro supports coconut crabs, seabirds, and reef fish, providing protein. Rainwater collection from vegetation and natural cisterns formed in the coral was possible during periods of precipitation. The island was not entirely without resources. A campfire site on the island's southeastern shore, identified and excavated by taiga archaeologists during multiple expeditions, showed evidence of repeated use and contained artifacts including bones of fish and birds, fragments of a glass bottle consistent with the 1930s, and what appeared to be improvised tools. The site's location, near the area where the 1940 bones were discovered, is consistent with a person using the southeastern shore as a base camp. The critical constraint was fresh water. Nikumaroro has no permanent freshwater source. A person relying entirely on rainwater collection and the liquid content of coconut crabs could survive, but only as long as rainfall was available. The castaway theory does not require a long survival, only that Earhart and Noonan reached the island alive, lived for some measurable period, and died there rather than in the ocean. The 1940 bone discovery fits that timeline and geography, with a specificity that continues to compel serious scientific investigation. Physical evidence found during a taiga expedition in 1991 on the uninhabited shore of Nikumaroro consisted of a sheet of aluminium alloy with a distinctive rivet pattern that researchers spent more than 2 decades attempting to connect definitively to Earhart's aircraft, an effort that illustrates both the power and the limits of forensic material analysis. The piece, catalogued as Artifact 2-2-V-1, measured roughly 19 inches by 23 inches. It had been cut and modified in ways consistent with use as a patch, a repair panel applied to an aircraft fuselage. The alloy type and thickness were consistent with the materials used in Lockheed Electra construction in the 1930s. The rivet spacing and pattern were analysed and compared against Lockheed factory records and surviving photographs of Earhart's specific aircraft. In 2014, Taiga published an analysis arguing that the artifact's rivet pattern matched a window repair that had been made to Earhart's Electra during a stop in Miami before the final Pacific leg. The repair was documented in a photograph taken during the Miami stop. The rivet spacing in the photograph and the rivet spacing in the recovered artifact were, according to the analysis, consistent within measurement tolerances. The peer review response was mixed. Some analysts accepted the identification as plausible. Others argued the tolerances were too wide to constitute confirmation. The piece was not the aircraft itself. It was a fragment whose chain of custody from the island to a verified connection with the Electra required several inferential steps, each of which carried uncertainty. The ongoing value of the artifact is less as definitive proof than as a physical anchor for the Nikomororo hypothesis, a reason to keep investigating, to keep sampling the soil and sediment of the island for biological material that the DNA techniques of the 2020s might read where the techniques of 2011 could not. Archival photographs found in the collection of the United States National Archives in 2017, identified by a journalist and former government investigator named Les Kinney, generated international attention when they were proposed as evidence that Earhart and Noonan had survived their disappearance, been captured by the Imperial Japanese Navy, and were being held as prisoners on Jaluit Atoll in the Marshall Islands. The photograph showed a group of people on a dock in what appeared to be the Marshall Islands. One figure, seen from behind, appeared to be a slim Western woman with short hair consistent with Earhart's documented appearance. Another figure appeared to be a tall Western man. The image was undated and had been filed in a folder related to the Marshall Islands. Kinney and the television documentary that broadcast the finding argued the figures were Earhart and Noonan, held by Japan after being captured following their disappearance. A Japanese military historian and blogger identified the image within days of its public release. He located the same photograph in a Japanese-language travel book published in 1935. 2 full years before Earhart's disappearance in 1937. The image was not evidence of her capture. It was a pre-existing document that had been misidentified and removed from its original chronological context. A separate theory, persistent for decades, held that Earhart had survived, been secretly repatriated by the United States government, and lived out the remainder of her life under the assumed identity of a New Jersey socialite named Irene Bolam. Bolam, who died in 1982, denied the claim emphatically and sued the publisher of a book advancing the assertion. The lawsuit was settled. DNA analysis, subsequently conducted using samples obtained from Bolam's surviving relatives and compared against the established Earhart maternal line profile, found no genetic match. The result was unambiguous and unreservedly clear. Irene Bolam and Amelia Earhart were 2 different people. The theory is forensically closed. Biographical records found in the Earhart family archives, held at Purdue University, document a family history and personal psychology that researchers have examined in the context of what behavioral genetics has more recently described as the heritable dimensions of risk tolerance, sensation-seeking, and the drive toward exploration. Earhart grew up in a household that was, by the standards of the early 20th century, unusually permissive about female capability and ambition. Her mother, Amy Otis Earhart, deliberately exposed her daughters to experiences considered masculine at the time: mechanical tools, physical challenge, outdoor activity. Her father, Edwin, was an attorney whose career was periodically disrupted by alcoholism, a condition whose heritability is well established in the genetics literature. Earhart herself abstained from alcohol. The behavioral genetics of what researchers call high sensation seeking, the drive toward novel, intense, and complex experiences that characterizes many explorers and pilots, has been linked to variants in dopamine receptor and transporter genes, particularly DRD4 and the serotonin transporter gene. The research is correlational rather than deterministic. The gene variants are associated with the trait in population studies, not predictive at the individual level. But the pattern of Earhart's life, the consistent preference for the difficult route, the repeated willingness to attempt things that the majority of her contemporaries regarded as impossible, is consistent with a behavioral phenotype that has a measurable genetic substrate. Earhart's private correspondence, some of it not widely circulated until the 1990s, reveals a person who was more uncertain, more physically tired, and more aware of risk than her public persona suggested. Her health in the months before the final flight was not optimal. She had recurring sinus problems and had been exhausted by the first aborted round-the-world attempt earlier in 1937. Sonar imaging data released in early 2024 by the company Deep Sea Vision showed an anomaly on the floor of the Central Pacific Ocean at a depth of approximately 5,000 meters, with a shape and size roughly consistent with a twin-engine aircraft of the 1930s. The location of the anomaly was approximately 100 miles from Howland Island, within the range envelope of where the Electra might have gone down if Earhart had flown past the island without locating it and then descended into the water when the fuel ran out. The image was captured by an autonomous underwater vehicle during a survey mission specifically designed to search for the aircraft along the most probable flight path extension from Earhart's last confirmed position report. Deep Sea Vision announced plans to return with remotely operated vehicles capable of descending to 5,000 meters and obtaining high-resolution photographic confirmation of whether the anomaly is an aircraft, a geological formation, or other debris. At that depth and pressure, an ROV would need to maneuver carefully around an object that, if it is the Electra, has been corroding in salt water for nearly 90 years. Identification would depend on dimensional measurements and any structural details or serial number markings that might remain readable. The deep ocean and Nikomaroro hypotheses are mutually exclusive in terms of what happened. Either the Electra ran out of fuel over open water and went down in the ocean, or it landed on a reef and the occupants survived for some period on an island. A confirmed wreck at 5,000 meters depth would be difficult for the castaway hypothesis to absorb. A confirmed DNA match from Nikomaroro bone material would be equally difficult for the ocean crash theory to explain. Both investigations are active. The answer, when it comes, will be definitive. Scientific assessments found in the peer-reviewed literature on the Earhart case from the past decade reflect a genuine division among researchers, not about Earhart's historical significance, which is undisputed, but about which of the two leading hypotheses the currently available evidence better supports, and what additional evidence would be required to resolve the question definitively. The forensic genealogy team working on the Earhart DNA project, led by researchers at the University of Oklahoma, has established a reference mitochondrial DNA profile for Earhart's maternal line using samples from her verified maternal relatives. This profile exists. It is the comparison standard against which any biological material recovered from Nikomaroro or the ocean floor would be measured. The profile has not yet been matched to any recovered sample, but the technical infrastructure for making that match now exists, which was not true as recently as 10 years ago. Amelia Earhart's significance as a historical figure does not depend on the resolution of the mystery of her death. She was the first woman to fly solo across the Atlantic, the first person to fly solo from Hawaii to the continental United States, and a deliberate and effective advocate for women's participation in aviation and public life at a moment when those arguments needed making. The record flights stand regardless of what happened over the Pacific, but the mystery has kept her present in a way that a documented death might not have. The open question, the transmission that ended mid-sentence, the island with the bones, the sonar shape 5 kilometers underwater, has kept people looking, kept researchers returning to the Pacific, and kept the technology advancing to meet what the previous generation of instruments could not read. Whatever the answer turns out to be, the search itself has produced science and methodology that extends well beyond one aviator's final flight.